All right. One of our other shortcuts that we can use is the SSS shortcut, or side, side, side shortcut. This is different. I have to stress this. This is different than the side, side, side shortcut for congruent triangles. We are only dealing with triangles that are similar here. So we're not saying that the sides are congruent to each other. These sides are proportional to each other. So if the three sides of one triangle are proportional to the three sides of the corresponding sides of the other triangle, then the triangles are similar. So that's saying, in a less crazy sounding, so if AC, side length AC, over the corresponding side length XZ, see how they're both green, if that is similar, as in that ratio matches the same as side AB over XY, and that also matches the ratio created by CB and ZY, then these triangles are congruent. So triangle ABC would be similar to triangle XYZ. So it's all based off of the similarity of proportions that they create together. So let's look at an example of that to try to kind of solidify what that means. So we're going to identify if the triangles are similar, and if so, we're going to write a similarity statement and ratio from left to right. So I'm going to look at side lengths that could match up. So we're going to follow the same idea that A should match up with the first letter on the second triangle. So if A and D, so D to E would be possibly similar to B to A. So we're going to say AB over DE, and that gives us 15 over 18. I'm going to simplify this just to give us a better number to look at. So when we reduce this by 3, that gives us 5 to 6. And then if we look at F to E, we can compare that to B to C. So BC over EF. BC is 12 over 14.4. And if we reduce that, which I'm sorry guys, is easier to do with calculator, is also going to be 5 over 6. And then we take a look at AC and DF. So that gives us 10 over 12. We can reduce this by 2, which also gives us to 5 to 6. So we can say yes, similar. So I'm going to say A, triangle A, B, C is similar to triangle D, E, F. Okay, so let's look at another one, see if we can follow the same steps. So one thing I notice here with these triangles is I have AC being 12 as well as AB being 12. So these two sides are congruent. So what kind of triangle do I have? It's isosceles, which means that these two angles are going to be congruent to each other. And if I look at my second triangle, PM is going to be congruent to NM. So those two are congruent to each other as well. So I have another isosceles. So if I have two sets of sides that are congruent to each other, do I need to do 3 ratios or do I just need to do 2? Honestly, I just need to do 2 because I'd just be repeating the same thing. So what that means, so I have AC and I'm going to compare that to PM. So AC over PM, since these are congruent to AB over MN, they should come out to be the exact same thing. So AC is 12 over PM, which is 15. I can reduce these both by 3, which gives me 4 over 5. So I'm going to do the same idea with that third side that we're not dealing with yet. We haven't talked about, which is CB and PN. So I'm going to say CB over PN. CB is 8 over 10. These are both divisible by 2, which gives me 4 over 5. So yes, these are similar. So I can say triangle ABC is going to be similar to triangle MNP.